PowerPoint. Can others see the PowerPoint? I was having a hard time because I'm using my iPad and I also couldn't see my PowerPoint earlier. So I was worried about that. You can see it, you can't see it. Oh, it's so strange. Okay, I'm gonna try and, whoops, I'm gonna try it one more time where I like get out of everything. You can now, but you can see. Okay, good, good, good. Well, now I'm out. So let's get back in here again. When I logged in initially, I couldn't see it either. Share screen. So we're just going to reset everything just in case, right? You only see me. Can you see it now? Now I see it. Perfect. Okay, I appreciate that. Thank you. There's nothing worse than like going on and on and on and on and nobody could see or hear or whatever. So this is great. Thank you. Okay, so as always, the subject bulletin for math and of course the general information bulletin is going to be our source of information. Anytime I get a question about PATs, I always go to this document and look to see exactly from the source what the answer is. So it's our main document for math about what we got to do for this PAT. So I still haven't seen any practice questions, and I check once a week to see if there's practice questions. So something could have come up, but I checked a few days ago and I still don't see anything for new curriculum. Has anyone out there seen practice on Veretta or on, it wouldn't be on Learn Alberta, it will be on, it's definitely not on the Alberta Education PAT site because I was there today, but I haven't seen anything. Everything is still program of studies. So we keep waiting. This is what we do. I also want to ask before we get started, because I know field testing is starting really quick. Are you signed up for field testing? Is anyone field test? It starts May 13th. That's what I thought it was 15th, but that sounds like right. Yes, May in the teens is what I was thinking. Beautiful. And I believe, and again, don't quote me, I have to actually look at the document, but you can sign up for field testing right until the first day. So like if it starts May 13th, you can sign up until May 12th. I might be wrong, but I'm pretty sure a few of you are signed up. That's awesome. Let me know how it goes after your field test. Are you field testing A and B or just one or the other? There was no need to sign up. You're doing both? You should have to, well, I don't know. See, the problem too is that I don't have a class, so I can't even get in to see what the process is like. So I actually have no idea what the sign up process is. From what I understand though, you have to like choose a day and a time. You have to like go through a process, but I don't know. Don't quote me because I don't know. I just know you sign up in Veretta, exactly like you said. Yeah, you signed up in Veretta and you chose a date and a time, I believe, or they assigned you one. I'm not exactly sure. Yes, cool. Okay, did you have to get admin approval to do it? That's what I read, that your administrator has to approve it. There's like an admin portion of it, but I'm not exactly sure. Regardless, if you're not signed up, this would be the best way. She pre-approved. Love it. That's fabulous. This is going to be the way to see the questions. It's the field test. So if it's also a great opportunity to get your kids practicing in Veretta if they haven't been in it yet. This is the perfect way to get them to practice and play, get them to play with all the tools, like get them comfortable playing with everything that is built in there. But yeah, this is how we're going to see the questions. So that's all we can do. Let me just close my window here. Someone's singing outside. Okay, well, that's great. Let me know how it goes. Email me. Tell me how you did, what you thought of the questions, how your kids kind of felt about the questions. I'm very curious to hear how it goes next week when it starts going. So great. Okay, so let's get into patterns. patterns, there's this is the organizing idea, and it's one outcome. It's very related to some of the other outcomes, and so now as we've dug in really deeply in, you know, if you've been teaching this for this year and last year, you'll start to see some of those connections here. So connected to algebra and also connected to coordinate geometry to build some of those sort of cross outcome connections here. But essentially our outcome here is that students investigate functions to enhance understanding of change. So our verb here is investigate, which means they're going deeper than just solve. They're doing like lots of, you know, identify, describe, represent, write, recognize, determine, investigate, and then of course our solve problems at the end. So we know we're going to see word problems on this outcome as well. But lots of playing around and digging into this outcome. I identified or highlighted some of the key words here. There's some vocabulary in this one, in these cusps: variable, values, function, table of values. These are important words to just work into our math classes and get kids understanding and hopefully also using some of this math language. These two vocabulary words here are important, and I would bet money that there's going to be a question, because these vocabulary words, independent variable and dependent variable, lend very well to a question. I'm guessing like a drop down, you know, this value is the independent variable, this value is the dependent variable. That would be my guess, or a drag and drop kind of thing. But ensuring that students know what these two words mean and how to identify them in a set of values, right? So the independent variable is the x coordinate, the dependent variable is the y coordinate, and the dependent variable is the one that depends on the value in the independent variable. We'll talk about all of this when we look at some examples. So key vocabulary there. Make sure they know those two words. You'll also see Cartesian plane in here. So I'll show you some examples of how we can tie this work into Cartesian plane. Yeah, so they have to identify the two variables. They have to describe a rule. They have to represent the variables on a Cartesian plane, and they have to write an algebraic expression that represents a function. So these two are kind of connected. Well, I'll show you some examples of that too. And so on. So those are kind of the key things in this outcome. Has anyone taught the patterns yet, or are you working on it right now, or you are yet to teach it, which is totally cool? How did your kids do in it? How did you do it? Taught it already? Working on it right now? Perfect. So timely. Starting it next week, Bianca. Love it. Haven't done it yet. Okay. Taught it. Cool. Okay, this is perfect. Perfect, perfect. Perfect timing. That's great. Okay, so with functions, some of the vocabulary, just being able to talk and speak to some of the things that we see here. This I took from mathology.ca, one of the grade 6 lessons in there. But what we have here is a table of values and a graph on a Cartesian plane. And so in our table of values, we'll see that we have a number of tickets, which is represented as the variable N, and then the cost, which is represented by the variable C, and that cost is in dollars. So talking through what we see, what we notice, what we wonder, and then Mathology has us asking students this question: what real life situation does this table of values and graph represent? And so what we see here is that depending on the number of tickets that you order, the cost of buying those tickets increases. So if you buy one ticket, it's going to cost $9. If you buy two tickets, it's going to cost $18. Three tickets is $27. So this is a proportional relationship that continues to grow at a steady rate. If we look at the graph, what do we notice? It's straight line, right? Straight line up. It is very proportional. It will continue on in that way, at least we can predict. So we want students to notice that as one variable increases, the other variable also increases. We want them to see the straight line on the graph. We want them to see that it's constant change as we move from one point to the next. both in the table of values and on the graph. These are the important pieces to sort of notice about this problem. We want students to know the word variable and be able to use variables. And this is what that algebra connection, right? Where maybe we want to figure out what, the cost of 10 tickets is. So it would be like, what is the cost of N? And so bridging it to algebra and understanding that connection, using variables to find unknown quantities. And then this is that dependent and independent variable piece. So here we're saying that the value of C is the dependent variable because the cost depends on how many tickets you buy. We don't know the total cost unless we know how many tickets are purchased. So it's dependent on the other variable. And this C is on the Y coordinate of the Cartesian plane. Okay, and that came like right from the curriculum that they have to see that the dependent variable goes on the Y. And then the independent variable is the N. It's the variable that just exists, and it can be any possible number. And the independent variable goes on the x-axis of the Cartesian plane. Okay, so that goes through some of the, not necessarily the solving and the doing, but just the laying the groundworks for the function work within this outcome. We're all good with these kind of things. So if we look at this graph, this one is also from Mathology. We have on the left side of the table of values the number of granola bars, which is N, and then the mass in grams, which is represented as M. So which one is the dependent variable? The number of granola bars or the mass? Dependent is dependent on something, which would make this the D, or the mass, sorry. Yeah, thank you. Good, thanks. The mass is the dependent variable because it's dependent on how many granola bars you're weighing, and the mass goes on the y-axis. The independent variable is the number of granola bars, and it goes on the x-axis. Okay, so that one is fairly easy enough. It's just some vocabulary work. But of course, when we're working within or with these tables of values, we also want students to be able to find both the rule and the algebraic expression for this table of values. Now, this table is also from Mathology, and I asked everybody in our office today, maybe somebody here knows, but I can't figure this out. What do sleeves have to do with juice boxes? Look, I don't know what the correlation is there, but the number of sleeves, like if you have one sleeve, you'll have 3 juice boxes. If you have 2 sleeves, you'll have 6 juice boxes. 3 sleeves, 9 juice boxes. So we can see that there's a relationship here. I don't know. If anybody knows what a sleeve means in relation to juice boxes, please inform me. I couldn't find a single person today who knew. I think this is weird. I think the kids would think it's funny. That's what they're called when they're wrapped in plastic. Oh, that's what it's called? Like you buy a sleeve of juice boxes? Oh, I have never used that language. Do you use that? It's usually groups of 4 or 3. Oh. Like, yeah, it's like wrapped in the plastic wrap, and then you like unwrap it, and the 3 or 4 juice boxes are in there. I thought it had, I don't know. I didn't know what it was. I have never called it a sleeve. I would just call it a package. I don't know. Thank you. That's impressive. I was like, Mathology's from Ontario. Maybe this is like Ontario, like some Ontario slang or something. I don't know. I have no idea. Thank you for that. So we want to be able to not only interpret, but also create a rule and an algebraic expression. I would work with these first before we start creating them, because creating is the trickier part. But understanding what the rule means. So here with our sleeves and our juice boxes, we multiply the number of sleeves by 3 in order to get the number of juice boxes. And so we can represent this as an algebraic expression as 3n, or b equals, or as an equation, algebraic equation, b equals 3n. So 3 different ways to represent that one technically. And so we can talk about this, we bring in that algebra piece. So how can we use this equation or expression to figure out how many juice boxes are in 12 sleeves? And so the 12 would slot in for the n there, and it would be 3 times 12, that'd be 36 juice boxes in 12 sleeves. So doing some of that work with students to interpret and be able to extend the table of values. But then they also have to be able to find the rule and the algebraic expression and equation. So if the number, if the number of sleeves here, if these values are regular, 1, 2, 3, 4, then what we can do is find the difference on this side, so long as the difference is stable. So what do we do to get from 3 to 6? Well, we either multiply it by 2 or add 3. But then what do we do to get 6 from 6 to 9? We can't multiply by 2, that would be 12. So it must be add 3. Is that consistent the whole way? Yeah. So each of these is plus 3, plus 3, plus 3. So because we add 3 each time, we can then multiply the n value, like n times 3, in order to get that value, right? 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. So that's sort of the quick and easy way to get that one, or to figure out what the equation is, or the algebraic expression, find the difference between the values. Now, there's sometimes that we have to do more. This is like a one step. This is an easier one. I would start with this, easy numbers, but it can get more complex. Like, how about this one? You can't really do it in the same way, right? Like 1 to 5, this is times, well, what's our difference here? To get to 1, from 1 to 5, it's plus 4. Does that work for all of these? 5 to 9 is plus 4. All of these are going to be plus 4. So what we'll do is multiply the term number times 4, but we're not finished. 1 times 4 is 4, but then we have to do something more to get it to 1. So how do we get from 4 to 1? We subtract 3. Same with this. 2 times 4 is 8, minus 3 is 5. 3 times 4 is 12, minus 3 is 9, and so on. So our rule here would be, to get the term value, we're going to multiply the term number by 4 and then subtract 3. Our algebraic expression is 4n minus 3. Our equation is v equals 4n minus 3. And it's also represented here in this way. So then we can do other things like use the expression to find the term number for term, or the value for term 12, right? We don't know what it is, but we could use this expression? Well, we would go 12 times 4 minus 3. 12 times 4, is that 48? 47, 65, is that 45? I think so. If I'm wrong, you can tell me. We should be able to find any number at this point. Are we okay with functions? This is an example of a two-step function. It would build up to this. This is a little bit trickier, but it's pretty similar to what was in the program of studies. So it should be okay, fairly okay. Perfect. Have you seen Polypad? Has anyone used Polypad before in math? going to show you Polypad here. Oh, did it share? Share Polypad. Polypad is a free app. You can just go to polypad.com, but actually I'll put this specific link in here because this link will take you right to the functions. You can give this to kids, but I kind of think this would be fun to put on the board as like a problem. So this is called an input-output machine. There's lots of these on the internet too. I know Gizmos has some input-output machines, or function machines is another way to call it. But essentially we put an equation into the machine and then we put a number into it as the input, and then it spits out an output. So with Polypad, what we do is I clicked tabulate, and then it's going to give me a table of values. And then I can click, I call these timbits. I click these timbits to like just change up the things here. So my expression here is going to be x plus 1, but I'm not going to show the kids that. So before they see this screen, I'm going to turn off the show the expression. And so then I'm going to grab a number and I'm going to put it into the input machine, or the function machine. So I'm going to take a 1. I'm going to put it in, and it's going to spit out a 2, and see how it starts to build my table of values here. What if I put a 2? It made a 3. And then if we put in a 4, and so we can continue to put numbers into our function machine, and it will build this table of values for us, and the output is actually the number that the output is. And so I think it would be fun as maybe a warm up or a math talk to see if the kids can guess the function, if they can guess the expression that we put in here. And then once they get it, maybe they write it on a whiteboard or something, we can show it. It's just plus 1, right? The number plus 1. We can then change this, which would be fun. We can click here. So what if we do x, what if we do like 2x minus 1 as our function? I'm going to delete this table. I'm going to click a new, oh, I want a new output. Tabulate. It's not letting me do that. Doesn't matter. I'm going to put a 1 in here, and it's going to give me a 1. But I do want to, oh, there we go. Perfect. I'm going to put a 2, and it multiplies it by 2, and then subtracts 1. I can put an 8, and I get a 15. You can pick whatever number you want. I can put a 21, and it gives me a 41. So this is an example of a tool that you could use maybe as a warm-up or as practice, or the students could even come up and put their function in, and maybe we have to guess what their function is. That's how I thought you could play this one, but I don't know if you have any other ideas or if this sparks something that might be fun to use in your classroom. But this is Polypad. This is totally free. You just go to the website and start clicking around with the tools. And I love Polypad. I use it for a lot of different things. So I wanted to show you that one as something that you could bring in. Any thoughts about that one while I get my screen going back here? Or any questions? Or has anyone used Polypad before? Looks fun. Yeah. Well, hey, we'll keep going here. Potential PAT questions. Again, we have no sample questions so far. However, when it comes to the actual value of like tables of values, you could go back and use looks good for reviewing. Yeah, I love that. Like as a review activity or review task. Totally. Yeah, it's really cute. You could go back to previously released PAT questions because this table of values work is fairly similar to the program of studies. It's just not going to include the new language like the independent and dependent variables. And then I'm starting to forget the program of studies now. I don't think that it included the Cartesian plane, but I might be wrong. If you remember program of studies, if that piece is new or not, I don't remember offhand. But the point is use previously released PAT questions for this because it's not that different. They'll at least get a sense of what style the questions are. These ones I found from Mathology, and I like that they've really updated this for the Alberta curriculum. Like they've really gone in and made sure that these pieces are included, the vocabulary pieces. So it's not perfect, but it's pretty good. The Cartesian plane was just positive numbers. Yeah. Yeah, you're right. And then they had to relate it to functions, right? And I don't think they have to do negative functions in our new curriculum. It doesn't say anything about that. So then that would be really similar. And maybe they did have to plot them. I don't know why I don't remember this. Regardless, they're still doing other Cartesian plane work. So this is fairly easy to plot on the Cartesian plane if they've done some of that work already. And you can jump back and forth between these units, same with algebra, kind of play around with them. So these are some of the questions here that are going to be very similar to what we'll likely see on the PAT around this. We know we'll have to identify the independent dependent variables. We know that we'll have to find a particular value using an algebraic equation. We know that we'll probably have to find a rule or pick the expression that represents the values in the table, right? So anything that we can do to get kids doing this work, but in context, because remember that solved problem thing was there. I think they had to plot function in a graph. Yeah, they might have. I forget to. I don't know. I don't remember. Oh, good. Oh, good. Here's another one from Mathology. I mean, these are good, right? These are good problems. They're going to be very similar to what we'll likely see. These ones, you could do these collaboratively too. The kids could work in small groups, like groups of 2 or 3, use a whiteboard to try and solve it. And then the important piece is like questions like this. How many video games can Zach buy and is there money left over? And this explain piece is the really good, juicy thinking stuff. The math long range plan has lots of examples of questions as well. So if you haven't checked out the patterns tab of the math long range plan, I linked it here, but it's on the elementary EPD site as well. And I went through it today and there's lots of questions, like tons and tons of questions that we could pose to students that are going to be very similar to what we will likely see on the PAT. So check out that resource as well. These are some questions that I found. These are all linked on the long range plan. And these are created by the APLC. It says ARPDC. They've changed their name since they published this, but the Alberta Provincial Learning Consortium, they made these or they adapted them from other textbooks. These are linked in the long range plans. And again, just good questions to ask that are aligned with our curriculum. So these are made in Alberta by the APLC, whose whole job is to help create resources for Alberta teachers, especially with a new curriculum. So there's lots and lots of questions in the long range plan too to get kids practicing. I kind of like this bottom one here, that 2 pencils cost $1.25. And so we don't have the table of values, they have to create it, right? Create the table of values. So they have to figure out how to sort of piece this information together and then write the algebraic expression that relates the number of pencils to the total cost. So that's a good one. I would do it again when students are finished. Do it with 2 pencils that cost $4.52, like build up uglier numbers, messier numbers. So lots of practice with this one. I think this one's going to be fairly straightforward. Knock on wood. We'll find out next week when those of you pilot. Thoughts or questions or ponderings? Is there anything that got sticky for students in this? Those of you who have taught this already this year or even last year? If there's none, that's cool too. I feel like in every one of these sessions, there's been so much like new stuff that today is kind of, it's kind of okay. Okay, if you're typing a question, keep typing. I'm gonna keep going. So that's patterns. It's not a huge outcome, pretty manageable, nice to tie in with other things. We'll jump into statistics. This one is also not a huge outcome. There's one outcome or a huge organizing idea. There's one outcome, two sort of chunks, but they're very closely related to each other. So we'll talk about some of the key pieces here. Trying to identify the dependent and independent variables is tricky. Yeah, I can see that. I can see that being, honestly, that's probably going to be the trickiest part of it. Well, and also creating the rule. Creating the rule for the functions is going to be hard too. Not hard, but it's going to be something that is going to require more practice. But yeah, the dependent and independent variables, I would spend some time practicing that. And just that conversation around which one is dependent on the value of the other one, right? The cost here is dependent on how many tickets we buy, or the weight is dependent on how many granola bars we have. EAL learners, totally, totally. And they're such similar words, right? Independent and dependent, that is a tricky one for sure. Like I said, I don't know, I just feel like this is really conducive to a drop down, right? Like, look at the table of values. This one is, and then a drop down, independent or dependent. And this one is dependent or independent, right? Like, I think that it's just going to be quite simple like that, which is good at least. But yeah, I can see that being something tricky. The rule was challenging in the program of studies too. Yeah, it was. I found doing what Jay did in her example of finding the pattern in the output column helped them to find the rule. Like I call them the bubble numbers, right? When I was teaching this in program of studies, yeah, like what is the difference there? And then multiply it by that number and then do whatever else you need to do. It was tricky. You're right. So at least it hasn't changed too much from program of studies. Yeah. And that's sort of the higher end of the skill set in this part of the curriculum. I would say try and get your kids there as best as possible. But if they can do the other things, like they can work with the equation, that's great. Stay there with them, get them really confident working with the uh, pattern rule or the algebraic expression or equation, and then start to bridge them into creating it. But it's okay if they're not super proficient in it. You had your kids do that too. Yeah. Just giving them the steps to do it, right, is really helpful. Okay, thank you. That's great. Appreciate the conversation. Okay, statistics. Now, statistics is not a wild, crazy difference either. The biggest piece in statistics is the vocabulary changes. So this is one of the organizing ideas where a lot of vocabulary has changed from the program of studies. So the big pieces in grade 6 are relative frequency, and relative frequency is right in our outcome. So 1000%, this is going to be on the PAT, the words relative frequency. I would bet a lot of money on this that it would be on the PATs right in the outcome. So this word relative frequency is replacing the word experimental probability. So if you are using textbooks or any sort of resources that aligned with program of studies, it's okay. That's great. Keep using that. But just make sure that you're bringing in like, oh, we don't actually call it experimental probability. That was so 2022. We now call it relative frequency, and just make sure that that vocabulary is coming in because they'll have to be familiar with this term. The word theoretical probability is our program of studies. It's been replaced with expected frequency, but they don't have to, this isn't part of grade 6. So, but just know that like there's vocabulary changes. So just put an X there, like don't worry about this one. I don't expect this to see this on the PAT, and they don't have to solve for the expected frequency, but you might see things like from previous grades, or we could see it in the junior high when that curriculum drops, that there's just been some language changes. But the big one that affects grade 6 is relative frequency. That is what the word is called now. So relative frequency can be expressed in 3 different ways: decimals, fractions, and percentages. And this is one of the pieces about the new curriculum that I liked right off the bat, because this brings the statistics outcome into our number outcome. And so when we're doing decimals, fractions, percentages, we can tie that into statistics so naturally. So so I kind of like that piece. So relative frequency as a decimal fraction percentage, we'll talk about that. And then the other piece here is about probability of events. Now, I think, and you can disagree with me, that's cool. And I'm also having a hard time remembering the program of studies. I feel like this is less than what was in the program of studies, because all they have to know here is equally likely outcomes, events. They have to be able to like identify the outcomes, collect data, predict the likelihood, not calculate the likelihood. We'll talk about this. It's predict the likelihood, determine the relative frequency. That's the calculation piece. Describe the likelihood using relative frequency, analyze statistics. They've specifically outlined different types of experiments. So expect to see these experiments on the PAT. And then this one, I don't know, like I haven't seen much about this, the law of large numbers. This just means that the more times you do an event, the better estimate you're going to have of the likelihood of that event. We might see it hit or miss, but it wouldn't be a bad thing to just introduce that idea that the more, if we only do a trial 5 times, it's not going to be as valid as if we do an experiment like 100 times, right? So there's not a ton in this one, which is good. And I don't know, I might be remembering things wrong, but I feel like it's less than what we did before. I should also say that grade 5 learns frequency, not relative frequency, frequency, and they relate that to the word mode. So mode is the most frequent outcome, and so in grade 5 they learn mode. So they could see mode on the PAT. I'm doubtful about it, but because they could use mode in order to answer a grade 6 level question because it's assumed to be learned, but I would be surprised. If anybody sees mode on the PAT field test or real PAT, can you let me know? I'd be very curious. I don't think we're going to see it, but just know that they are coming in with this idea of frequency already from grade 5. So when we think about outcomes and the likeliness of outcomes, the only one that is explicitly listed in the PAT is equally likely. I used to teach my kids about impossible and certain and all of that stuff. And I still would. I still think that it would be helpful to understand what equally likely means by also explaining what impossible and certain mean, right? I think it would be hard not to talk about those things, but they are not in the curriculum, which means they will not be assessed on the PAT. The only piece that's going to be assessed is equally likely. I just think that the work has to be done around it to do a good job of it. So for example, in spinner A, what is the likeliness of spinning blue? Well, it's impossible. And then which of these 3 spinners is equally likely to spin blue or red? Spinner C, right? They have equal number of outcomes. So we shouldn't assess and report on the other ones like impossible and certain and stuff. We would only assess and report on equally likely, but we can still bring these in to help. The other thing that will not be on the PAT, from what I think, is expected frequency. And so this is when you take the number of outcomes, like if we take spinner B, the total number, if we want to know what the expected frequency of spinning blue is, it's 1 out of 6. 1 blue outcome out of 6 total. And so the expected frequency is 1/6. They don't have to calculate this. But I don't think that I think this ties so nicely into fractions that I think that you could still do this work, but they don't have to. But you might see resources that have this. For example, mathology.ca has expected frequency. Everything you see on the screen today, I took from mathology.ca. So even though they've done a lot of work to like truly align with the curriculum, there are some things in there that are not specifically the Alberta curriculum. However, I don't think they're beyond what we could be teaching. I also kind of like that they put the expected frequency fractions on a number line, because number line sense is really important, and that is in the curriculum. And so this wouldn't be a stretch for you to do these activities with the kids. Just know that they won't see this specifically on the PAT. We don't have to assess and report on this specifically, but it could tie into fractions and number lines and other kinds of things, if that makes sense. The only one you're going to see here is equally likely. Okay, cool. Okay, so relative frequency is the number of the frequency over the total, the number of times that, so I should clarify actually, expected frequency is before the experiment, right? What do we expect the frequency of rolling spinning blue is? Relative frequency is after the experiment, and it's the number of times that that outcome came up over the total number of times that the event, or total number of events that happened. So we have this tally chart here, favorite activities in spare time. I feel like the PAT will have something very similar to this, and they will ask to express the relative frequency of reading in a decimal, a fraction, and a percent. So we'd have to figure out how many events happened in total. And so this is, there's 100 altogether. So our total number of events is 100. And so to find the relative frequency of reading as a fraction, this would be 20 over 100, or we could reduce this to 2/10, or we could reduce that again to 1/5. As a decimal, 0.2. And as a percentage, 20%. That's it. So this ties in so nice with so much of the work that we do in number that it would be cool. I mean, like, we're still learning this curriculum, right? But next year, when you're doing some of this like fraction work, decimal work, percentage work, to jump over to statistics and use some of this relative frequency work in order to teach these skills in context. Because there's just lots of like multiplication and scaling and fractional sets here. The big piece here that I want to reiterate, this is like, if you take away anything from this piece today, it's that kids can't use a calculator on the PAT. So we know that the numbers are not going to be hard. So when we're giving kids practice, if you're using like resources from Teachers Pay Teachers or somewhere else, they don't often like think about these things, and they'll give kids like crazy numbers, like 18 trials, and you have to figure out what like 7 out of 18 is as a fraction, a decimal, and a percent. Like, what? No crazy numbers. So when you're giving kids like a table like this and they have to calculate the relative frequency, make the number of trials an easy number for this work. Like 10 trials, 20 trials, 25 trials, 50 trials, 100 trials, and make all of the frequency numbers a multiple of that number. And so that this work it doesn't have a huge cognitive load because they can't use a calculator. We're not expecting huge calculations. We're looking for understanding. And so they want to see that the kids understand what relative frequency means and how to calculate it, not that they have like crazy multiplication skills. If that makes sense. Well, here's some PAT questions. I got these from Mathology, and like I said, like Mathology goes a little bit too far. You could still do it. There's still curriculum connections to everything that's in there, but if we're thinking specifically the statistics outcomes, I didn't choose the slide decks here for this one. I actually went into the printable practice pages because these ones I thought were better examples of potential PAT questions. These would be great to do in small groups as well. You don't have to give them the whole like package of papers. You could do one at a time in small groups, for example, or as a class, but see how the numbers are all friendly, like 25 grade 6 students, right? So when we're trying to figure out the relative frequency of swordfish, which is 5 out of 25 is an easy number to work with. There's not a huge cognitive load to be able to figure this out. This one here, the batting baseball practice, 50, 60, 70. Yeah, this one is kind of a weird number. It doesn't matter. Anyways, those are in there. This is kind of the thing that we're going to see is just calculate the relative frequency. There was no problem solving in this one, right? There's no problem solving down here. So it's not really about solving complex problems. It's more just about figuring it out, calculating it. So you can do lots of practice with that. And also in the math long range plans, the statistics tab is there. And there's a ton of questions that are just like this that are going to be really similar to what we see on the PAT. So really the number one thing I would say is that the vocabulary, that relative frequency, make sure they know what that means and then how to do those calculations and be able to do it in a fraction, a decimal, and a percent. Thoughts about this one? Does anyone? Poor statistics, right? It's like that unit that is left to the end. I think though with this new curriculum, there's a better opportunity to tie it in throughout the year. We always say that, right? But how do we authentically tie this in throughout the year? I think the relative frequency gives us a good opportunity, but let me know what you think. Has anyone done this one yet this year? Or was there anything that kids were stuck on in statistics? Any weird questions that came up? I feel like in a lot of the other organizing ideas, the concepts got moved down from higher grades. This one sort of stayed easy. Used a survey to create their own tally chart. Yeah, I love that, Richard. Totally. They can create their own tally chart and then calculate the relative frequency, tie it into graphing. Yeah, make some graphs about it. That's perfect. Give that ownership a little bit of the data, which is great. If you're doing something in science or something even like if you school did student vote a couple weeks ago, right? Could you find the relative frequency of the Liberal Party winning or the Conservative Party winning, cross-curricular with social and science? Exactly. Yeah, anytime you can find an opportunity to gather some data and then find the relative frequency of it, try and do that, thinking forward into next year so that they have lots of experience with this one. I think that cross-curricular piece is the key here. Otherwise, statistics is that unit that is at the end. That happens to me so many times too, right? Like we're going to do 2 days of statistics because I'm running out of time. So tying it in as much as we can with other subjects or things going on in our school, different events happening at our school, that's the key, I think. But it's fairly fairly simple, like fairly straightforward, I feel. So this takes us to the end. On the elementary EPD site, on the grade 6 PAT page, I've posted all of the recordings as well as the slide decks. So I'll post this one there as well. So if you missed any, or if you have colleagues at your school or at other schools who missed some or had no idea that this even happened, all the recordings are going to be there. We have a PD day on May 16th. Is that next? That's next week already. We have a PD day next Friday, and the afternoon is a teacher choice time. And I'm doing a session with Jackie, who's here today. We're doing a session on building thinking classrooms. So we're going to be like live from Jackie's classroom, and she's going to show you some cool things that she does in her room to get kids thinking. So if you're interested in that, sign up for our session on May 16th. But if you missed one of these sessions, one of the 5 in the series, or you have colleagues who missed some, that afternoon, you can watch these videos instead of signing up for something. that would be completely fine. I was going to put them into the, anyways, doesn't matter. If you need to catch up, or if you want to rewatch one, that May 16th PG Day teacher choice portion of it would be a perfect opportunity to watch some of these videos. So they're on the Elementary Math EPD site. I also recently just updated the long range plans for grade 6, and I'm updating them as the APLC creates more CPAR documents. And so I added 2 for grade 6, but I don't even remember what they were. How funny is that? I don't know. I'll look it up. So know that that's there if you need to get caught up, but you don't have time after work, which I totally understand, to watch them. And then tell your friends they can watch they can watch the PAT at the videos at that PG Day as well. I'm going to share this. So as we come to the end, since I sincerely thank you for coming to these sessions. 5 sessions for like math is seriously unheard of. No, what, like, this has never happened before. So thank you so much for signing up. And I am so excited to hear how things go over, well, for the field testing. Email me, let me know. I'm so curious how the field testing goes. If you're signed up, if you're not signed up, sign up. I think you can see my screen here. I added prime factorization and exponentiation to number, and then also multiplication and division. That's what I did. And I added patterns to grade 5. Would you recommend linking algebra rules for functions, coordinate geometry together? I don't have time this year, but next year. I feel like that. Like, let's put that out to the group. Like, how do you feel about putting together some of the algebra, the functions in the patterns, and coordinate geometry? Like this, it kind of lends itself to spiraling back, you know, where you can kind of hop around. I don't know in my head how I would map it out quite yet, but I think you're onto something, Richard, and I think that would be a really efficient and cool way of doing that work. Put it in the chat if you have ideas about that, or if you're kind of thinking the same thing, because I want to update the long range plans too to include some of these, some of the like cool ideas and like brilliance we come up with. And I think that that's the way to go. And yeah, next year, totally. Regarding earlier about independent, dependent, it has connections to science vocab. Oh yeah, Bianca, you're totally right. Like the independent variable and the dependent variable, and then the controlled variable. Mic drop. You're right. So looping that into science as well. And they mean the same thing. The dependent variable is dependent on whatever it is that you're changing. And is that new vocabulary in the new science? Because was it not like manipulated, responding, and controlled? Is this new in science? Or am I really out of the loop? Yeah, it's new. Okay. Okay, so I didn't know that. That's perfect. That's such a good connection. I might add that to the long range plans too. That's really good. I taught manipulated. Exactly. Oh, but now it's the same as math. Okay, well that's good. That helps a lot. It works well because students see different ways to show the same information. Exactly. That math is like this work that we do is related to so many different things. It's not just siloed in one unit. It's almost like, I don't know, like this is a bold statement, but like, do we even have math units anymore? Maybe it's too soon. I don't know. But there's so many connections and ties to other things that it would be hard to even unitize this work because it is so tied into the other things. So that's just a crazy thought. Great questions, great ideas. I love this. And I'll show you where the math PAT stuff is too on the main page. And I always update this. So I keep this what's new super up to date. So I just updated it last week. Grade 6 provincial achievement tests. There's a quick link for it. And then all of the recordings are here. 1, 2, 3, 4, and then 5 will go here. And I put the slide decks down here. So that's where it'll be if you want to watch. Okay, well, thanks everyone. Let's stop recording.